Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you on a very long, exhausting day today. I'm going to wrap up with this video though too. You can step into my virtual classroom though. I will allow you to do that today. More on sequences here. Sequences, we've been looking at equations of sequences in explicit and recursive form and building a list. And then the last video, we took lists of arithmetic sequences only and built their recursive and explicit form. I'm going to be dealing only with arithmetic sequences really the rest of the way for this unit. Geometric saved for a different time, really. And what I'm going to do today is I'm going to take a broken list, something where you know a term and another term that's separated from it. And we're going to piece it together, finding out the missing terms of it. Knowing that it's an arithmetic sequence, that's going to help because that can allow us to say what kind of pattern's occurring, so we can find out how to get the other missing values. And that's the whole goal for this video. Now, at the risk of sounding too repetitive for it, there are 12 total problems, and I'm going to only take half of them. I'm going to do the odds. I lied. I'm going to do the odd problems, and I'm going to do the very last problem, the number 12, because it's a fraction-based problem there. I'm going to find different ways to do all the different problems to kind of diversify it and say, here are different ways you can do it. But I'm still trying to make this as short and sweet as possible. So let's go and get started here. In terms of doing so, one second. All right, there we go. Okay, in terms of getting started here, you can see this, again, ignore the evens or look to them for your own practice, for your own sake of it. I'm going to focus on the odds here, and here are the instructions. Find the missing term or terms in each arithmetic sequence. Now, it is important to note that this sequence is arithmetic. If this were a geometric sequence, you would get a completely different value here that's reasonable, something that you can actually calculate. Completely different value here because you'd be finding a missing term from a common ratio instead of from a common difference. So our stuff here is all based on common difference and all that. First two problems that I actually even do, numbers 1 and 3, I'm going to avoid even using the word common difference. I want to see if you can see any other logical ways of attacking problems outside of just guess and check. Ways that you can calculate and get these values by saying, if I knew nothing about sequences, could I still achieve the achievable? So let's try that for numbers 1 and 3. Again, at the risk of sounding repetitive here, I want to find different methods. All right, number 1. I have a list here. The only thing you got to know is that the everything in between is like equal length apart. So number 1, I have a sequence. I don't really want to use the word sequence, but I have a list here, ... some numbers, -31, some unknown number, I'll call x, -21, ... What is the missing value? What's true about doing something like this, where this value is equal length apart from these two, is if I consider to this be like on a number line, where -31 was here, -21 was here, then this missing number would be in the middle. Now, one way to do something that's in the middle that's kind of unique and different for two numbers is you actually can average your two numbers. If I take the average of two numbers, I have also created what's called the midpoint. And that's kind of a nice way of saying that if you ever want to find the midpoint of two values, you can average them. For the sake of practice, let's do that for this problem. How do you average numbers? You add them up and you divide by how many there are. For two numbers, to find a midpoint, you add those two numbers up and you divide it by 2. -31 plus -21 divided by 2 is going to give me -52 divided by 2, which is -26. So my midpoint, -26, which is also the average, is the missing number that's in between here. So, I found a nice fun way, not fun, found a nice different unique way to do it without any sort of semblance of sequences to say if I have one missing number between two numbers, I can average and find them. If you want to do the same thing, not going to do the problem, but if you want to do the same thing here, you can average these two numbers and get -30. See if you can try that for yourself. Averaging numbers doesn't really work now, however, when you have something like number 3, where there are two blanks in the middle, because I need to be able to find two numbers, not just one. And it is, they are equal lengths apart from one another from all four of these. So if I did the number line setup, I could still make something kind of happen here. Now, if this were a true number line, -36 would appear here, -6 were to appear here. But now that I have numbers in between that kind of create something that looks like this, now what I have, not perfect, now what I have is kind of equal distance between all of these values here. So let's say this were x and y. Technically, x would go here next to the -6, y would go here. So let me kind of give you a different approach, more of a logical step to go here that's not yet talking about sequences, but will still give the sequence route, just kind of not the terminology. What's kind of nice for this equal length thing is, what if I just found the lengths that were between all these values right here? That would be cool. In order to find those lengths, what would also be very cool is just to find the length between my two endpoints. Theoretically, my two endpoints, -6 and -36, well, they are the endpoints and I can find that length. It's 30. Excuse me, it's 30, right? If you don't know that, you can kind of do a 36 minus 6 thing. Kind of talking absolute value there when it comes to lengths. 36 minus 6 gives you 30. So those are the lengths. Okay, so in doing that, that means if I cut this into thirds, 30 into thirds, I'm going to get 10, which makes 10 the length here, 10 the length here, and 10 the length here. Now that doesn't give me the number for x. 10 is an x and 10 is an y, but I can use this 10 to find it by stating what's 10 away from -6 in the negative direction. You have to keep in mind, I'm using the number 10 just as a length, but I have to subtract 10. I have to go to the left because it's a number line. -6 minus 10 would give me -16 here. So that would be that value. And -16 minus 10 is -26. And appropriately, -26 minus 10 is -36. So it looks like x and y right here are going to be -16 and -26. And I'm sure you could have seen this, played some guess and check and gotten to that. But I had a way of calculating it now that kind of runs its own gamut. And it's one that I'm going to be using a little more down here, but I'm going to use it with sequence terms and a little more algebra. And I want to see if you can make sense of what I do here. It's a nice way of going about probably all of these, even for geometric sequences, because you've created an equation that doesn't just use distances only, but it uses the idea of what I'm going to start now saying, common difference. Okay. So what I'm going to do now for number 5 and probably 7 and such onward is you're going to see me use a little more algebra and tie it into how this even plays with that same effect. Number 5. Number 5, and you've seen me do this kind of thing before if you've watched any of my videos, if you're in my class, something like that. From one term to another, if it's an arithmetic sequence, that means a common difference exists. For a common difference, that means that I'm adding or possibly subtracting the same number over and over. For the sake of argument, let's pretend like it's adding, and if the number ends up being negative, we'll just subtract it anyway. So if I add some common difference d, of which I do not yet know what it is, I'm going to get this number. Recursively, if I take this number and add that same common difference right here, I will get the next number. And I can repeat this process a couple more times until I go all the way from this last blank to negative 817. So there are 3 blanks in between, but from this term to this term, I'm going to be adding the common difference 4 times to get all the way from -17 to -817. You can see as these ends in 17s, you probably can figure out what this is if they end in hundreds or something. But I can set this up kind of like an algebraic equation. See, I might not know what these numbers are yet, but if I find out what this common difference is, if I solve for this variable d, just like this 10 here, I can use that common difference to then get those numbers. So let's set it up like this. Exactly how it looks, but in a straight line. -17 plus d plus d plus d plus d equals -817. I might not know the numbers in between, but I do know that the difference in between is common, and there are 4 times that I add them. So what better way to write d plus d plus d plus d than how about just 4d? Like that. Okay, so at this stage here, we've set up a nice 2-step algebraic equation that we can then solve. I want you to see if you can draw a connection between the last problem that I did on number 3 and what I'm about to do from here on out in number 5, and say the logic that I used on number 3 can be used algebraically in number 5 as the similar tie-in, or vice versa. What I'm going to do in terms of solving for x, I'm going to add 17 to both sides to get d or solve for d, is add 17 to both sides here. -17 plus 17 is 0, and I get 4d equals -800. Okay, see if you can get that tie-in here. What is a -800 or positive 800 or what have you? Well, that's the distance between this number and this number. So when you consider what we did in the last problem, the distance between -6 and -36 was 30. I'm doing the same thing right here algebraically. I just arrived at it. I just had a more, algebraic approach to actually get what I got there. And then remember how I divided this into equal widths here by dividing by 3, the 3 blanks that were in between? That's what these distances here are from one term to the next, but there are 4 of them. So what am I going to do with algebra? I'm going to divide both sides by 4. And D will give us negative 200. Okay, so we found another way of getting it more in an algebraic sense. I'm probably going to use this approach a little bit more because common sense can be disrupted for several different reasons here. I know there's a specific problem I practice with some of my students, and I think the next problem will speak to that. But negative 200 is my common difference here. Okay, so I got this difference. That's great. I'm going to use this in order to achieve what I have to recursively through this arithmetic sequence. Plus D. D is negative 200. Plus negative 200 is the same thing as minus 200. So if I do negative 17 minus 200, well, that's negative 217, baby. Minus 200 again is negative 417, and it looks like minus 200 is negative 617. To confirm all that, minus another 200 does appear to be negative 817. You want to confirm that you landed on your last number as expected instead of just trusting your answer. Make sure that that answer does actually arrive appropriately at what you got. All right, if it's okay, I'm going to erase some of the work here to get this next problem brewing. Number 7, here's what I want you to be cautious of in case you want to try that number line approach. If you want to find the distance between the numbers 16 and negative 84, because I saw some students do this, they'll probably say that that distance is 68. All right, well, there are 2 issues with that. The first one being the distance is not 68, and I think that's the biggest issue. Second issue, like I said before, I would rather say something like you're subtracting the number from one to the other. But check that. Is 16 minus 68 going to equal negative 84? No, because even 0 minus 68 isn't negative 84. There's something you have to be careful of, and that's that the 84 is negative. If you ever want to find the distance between 2 numbers, you must subtract one from the other, but don't ignore its sign. That 84 is negative. That 16 is positive. On a number line, that would look like 16 here, negative 84 here, and guess what? 0 is right here. So if you wanted to go the logic approach, the distance between 0 and 84 is 84, and from 0 to 16 is 16. That whole distance, you don't subtract them. You kind of add them. That gives you 100. So the distance between them is 100. Keep that in mind if you're ever going to try that approach there. Technically, I'd want to say negative 100, so I'm subtracting. But I'm going to go ahead and go the algebra approach, even though I set that up. Remember that number, negative 100. It will be used. All right, how many times am I going to add a common difference here? Once, twice, 3 times, 4 times, 5 times. Okay? So 5 times in between the terms, you add a common difference from 16 plus 5 common differences to give you negative 84. Subtract 16 from both sides here to solve for D, and you're going to get 5D equals negative 100. Look at that. That's where the number shows up. All right? 5 intervals of that common difference gives you negative 100. Divide by 5, you get D equals negative 20. So 10 times less than that previous one here. Subtract 20 over and over. We're going to get our value. See if we can make sense of that. There we go. And 16 minus 20 is negative 4. From here on out, they get a little nice looking because I know they're all going to end in 4. That first one, I think people are prone to make mistakes. Those are the missing terms in between. I have accomplished what I needed to. The algebra helped take care of it. That is good. Okay, so you've seen a couple instances with the algebra. You've seen the tie-in with the common difference stuff. You know how to avoid making mistakes. I'm going to give you kind of one more instance. I want to see if it makes the most sense because eventually sequences go out of the frame. The reason why I'm teaching sequences here, or my school does, or in class we do sequences before things like linear equations, is because we want to find a very nice, handsome tie-in into using words and word problems and examples with nice, clean, whole number, n terms, and all that to build into what you would do when you create something called slope-intercept form. Now, I'm not going to do something regarding slope-intercept form or something right now, but what I'm about to do is very similar to what you would do if you want to find the slope between 2 points. Every time that we found what's called a common difference, that is using a rate from one term value to the next. For every term that I move over, I have subtracted 20 or added 5 or done whatever there. I'm going to use and apply that rule in a very more steadfast way. No algebra, no solving for D this time, but seeing if you can feel slope out here. Number 9. Ignore the ... So let's pretend for a second, and I don't have to, but I want to play this a little fast and a little easier for now, and I'll show you what I mean later. Number 9, pretend that 35 was your first term. This blank is the second term. Here's the third term, fourth term, fifth term, sixth term. Here's the seventh term. Okay. Ideally, what you're doing every single time here is, remember, I talked about the distance between your two values. I'm going to apply that thing right now. You want to find a common difference in a really fast way without any algebra or having to talk too much about number lines and stuff. All you got to do is take the difference between your two values here. And we've been doing the division, but I'm giving you kind of a formula-esque thing. And divide it by the distance between your terms. How far away is term 1 from term 7? Do 7 minus 1 to figure it out, right? It's 6. They're 6 away from each other. This, if you've done anything with slope before in your life, then you've seen m equals y2 minus y1 over x2 minus x1. You know what I'm talking about. If you haven't, and you're going to learn it later through some of my videos, be my guest. But in this case here, this is one of those kind of cheats to sequences. Arithmetic sequences are no different than linear equations if you really lay it down to the nitty-gritty. Just different terms, literally. Like d instead of m, things like that. All right, 89 minus 35. Let's go to town with this one. It's 54 divided by 6. We get 9. So your common difference is 9. It is a positive 9 here. I am adding 9 each time to get from one term to the next. Let's save face and just go ahead and add those. That's 44, 53, 62, 71, 80. And plus 9 is 89, so that seems to work out. So cool. Little slope formula going into play. But, you know, there was something implied here that you didn't see. And remember when I said pretend like this was the first term? What if it wasn't the first term? What if it was the nth term? Okay, well, this term is n plus 1, and this is n plus 2, and 3, and 4, and 5, and this is n plus 6. Well, what's the difference between n and n plus 6? Let's do n plus 6 minus n to figure that out, which is n plus 6 minus n. The n's cancel, and you're left with 6 anyway. It doesn't matter what numbers you use. I could start with a million right here. This will be 1,000,006, and I subtract, and the difference is still 6. So I said you might as well start with 1 as a general principle for what we're doing there. All right, so there's the fill out there. I got 2 more problems I'm going to do, numbers 11 and 12. 11 involving decimals, 12 involving fractions. No big difference between what we did before. I'm going to go back to the common difference play, though, just to talk about solving in algebraic you-know-whats. So this is the plus d thing again. How many times are we going to add d over? That's once, twice, 3 times, 4 times, 5 times. So I have 10.8 plus 5d equals 17.8. Let's go ahead and solve for d. Subtract 10.8 from both sides, you get 5d equals 7. Divide both sides by 5, you get d equals, this is actually, I'm going to go with decimals because these are decimals. That's exactly 1.4. So 1.4 is the number that's being added. That's my common difference between terms. No one ever said that the term values had to be integers. Even though the term positions themselves, for instance, would have to be integers, the values don't have to be. So 10.8 plus 1.4 here is 12.2, plus 1.4 is 13.6, and then we get 15.0, or you can just say 15, to 16.4, and indeed plus 1.4 gives me 17.8. So that cleans up. I was going to do that one fast. Number 12, I want to talk a little bit more here in the end, see if I can get within the 25-minute slot here. Let's see this. Number 12, a couple things to this one. This one involved decimals, and this one involves fractions. I'm going to have my common difference. If it has a fraction in it, I'm going to leave it as a fraction. Okay. There are 3 terms in between, which means there are 4 spaces to add a common difference. So see if you can roll with me here. My equation will set up as 7/9 plus 4d equals 19/9. Just a quick timeout. As you're watching this video here, if you feel like I'm going a lot faster with this thing, now start to ask yourself consciously now instead. You were asking yourself subconsciously, do I really like faster videos than shorter videos? Would I prefer that Mr. Robinson teaches this on a slower pace than on a faster pace? That's kind of your call. These are practice problems. You can go ahead and try the evens if you'd like and see if they make sense with every approach we did and try and repeat. But I'm going to do this one even for you. Okay. I'm not going to talk too much into how to do fractions as far as teaching, but I am going to be doing those things as I teach how to do the problem. I'm going to subtract 7/9 from both sides in order to solve for d. This is not the only way you have to do the problem. I will show you a different approach in just a bit. 7/9, I wrote it this way so you can kind of see common denominator, so you can subtract the top. Okay, so that gives me 4d equals 19 minus 7 is 12, and I have 12/9. It is very possible, or even likely, that you might recognize that these fractions here can reduce. And by and large, I would recommend that you do it almost fully. The one difference is that as we're going to be adding a common difference here, note that it's likely that I want to add something that has a ninths to it. I want to add something with a ninths because I want that common difference. So for the sake of argument, I'd like to keep this 9 here as long as I can. Otherwise, yeah, I'd happily reduce this to 4/3. Here comes a maybe tricky part, and I do kind of want to teach as I do with this one. I'm going to divide both sides by 4. Now, how the heck do you divide a fraction by 4? 12 divided by 9 divided by 4? It's actually 12/9 divided by 4. I want you to really emphasize the fact that that is the numerator. It is important because there's a difference between 12/9 divided by 4 and 12 divided by 9/4. Those are not the same answer, obviously. So, noting that it's 12/9 that divides by 4, you still ask the question, what do you do? Well, I'm going to recommend instead that you don't write it as over 4 as a fraction, but literally divided by 4 with that divisor symbol. I forget what the symbol's called. I learned it like a month ago. It actually has a name. It might start with an O or something. I can't remember. Anyway, I'm dividing this by 4 here. How does this help? This helps because dividing something, if I write this number in fraction form, like 4 divided by 1, dividing by a fraction is equivalent to multiplying by its reciprocal. So instead of dividing by 4 over 1, I could multiply by 1 over 4. Look at that. Now, I'm not, and then you would multiply straight across, but I'm not going to multiply yet until I reduce what I want to reduce. Now, I did state before that 12/9 could reduce to 4/3, but I also stated that I would very happily love to have a 9th in my denominator, so I would not like to reduce that. However, I could reduce this 12 and this 4. That 12 is dividing by that 4 once this multiplication came into play. Make no mistake, this is 12 divided by 4, which is 3 here and 1 there. 12 over 4 reduces to 3 over 1. So now I multiply straight across, and 3 times 1 is 3, and 9 times 1 is 9, so I get 3/9. The real common difference is 1/3 if you really want to write that, but I'm going to be using 3/9 when I add over because, again, common denominator. Now, that's one way that we could solve that problem. I'm going to do the 3/9 adding up here in a bit, but I'm going to take this equation that I wrote again. I'm going to write it one other way, one thing we could do. If you don't want to deal with fractions when solving a problem, you could always try and recognize what the least common multiple of your denominators are here. In this case, I'm dividing by 9 here and here. So what would be really groovy? No one uses groovy anymore. I didn't even use groovy when I was younger. What would be super cool is if I multiplied both sides by some number such as 9 that could actually eliminate my fraction. On the right side, this is very straightforward. This is a 9 divided by 9, just like this 12 divided by 4 occurred right here. That 9 is dividing by that 9. Make no mistake. It most certainly is. Same reason that was. Oh, you can't see that. Same reason that was right there. Okay. Now, so what's the 9 is gone on the bottom. All that's left is 19 on top. Now, you might say, hey, let's cancel out these 9s as well and write 7. You'd be right. But be careful. 9 isn't just multiplying by this term right here. It is distributing. We're multiplying 9 right here and right here. So 9 may cancel out with this 9, and all you're left with into this term is 7. But the other term, 9, still multiplies with 4d. And here I have 36d. So now I have a brand new equation here. No fractions. No fractions whatsoever. And I can solve for d. A little more simply, subtract 7. And there's that 12 that we saw before. 36d equals 12. Divide both sides by 36, and we get d equals. And here's where you might want to look to do some fraction reduction. If I divide top and bottom by 12, I get 1/3. But of course, I think it's better off that we use the 3/9 number instead of 1/3. But we got the same answer. If you didn't really know what I did here, you can ignore it and go with fractions. If you don't know what I did here, well, then you might be stuck on how to do this problem, because these are really the only two ways that you can go about it. Pick and choose one battle versus the other. Rewind the video if you weren't sure what I just did there. Last thing I have to write in is just add those 3/9 over, and I'll be done within that 25-minute span, which is coming up right here. 7 ninths plus 3 ninths, common denominator, add the top, you get 10 over 9. Plus 3 ninths again, we get 13 ninths. Plus 13 ninths, we get 16 ninths. Plus 13 ninths, we get 19 ninths. I was considering saying, hey, we could ignore nines completely and just pretend like it was just 7, 10, 13, 16, 19. But if these numbers were fractions within, like this wasn't actually 10, it was like 10.2, you know what I mean? If it was something like that, you don't want a fraction within a fraction. So I don't think we can just completely ignore. But in this case, we almost could, and then write the ninths later. All right, so that ought to do it for this problem set here. Again, if you want to look at these ones one more time, numbers, you can try number 2 any way you want to, but numbers 4, 6, 8, and 10. There they are for you. That's your nice, much shorter video, at least 20 minutes shorter than my normal ones. This is how we find missing terms in an arithmetic sequence. If you ever wanted to do a geometric sequence, you're going to have to know a thing or two about common ratios, in which case there will probably be a video someday down the line that I do with that if I explore that kind of thing with my class at some point here. Okay, so like I said, that ought to do it here. I'm Mr. Robinson. Take care. If you have a question, please leave it in the comment section below. I'll be happy to try and answer that one for you. Bye, fellas.